Hi, in this video I'm going to talk about another way of storing data so that you can get a better way of searching. So far we've done sequential search, which is the big O n, which means as long as n increases, the number of comparisons and the timing is going to take longer. And then we did binary search, which is a log n and log of n, which splits it into half each time you go through searching for a value. Now we're going to talk about hashing. Hashing is an O1 up to a point, and we'll get to that in a little bit. But the point I want to talk about on hashing is that um, you take the data, you come up with a hashing number, and that's where it's located in your storage device. We're going to use a list because it makes it a lot easier that way. So I'm just going to go ahead and kind of go through this a little bit with you. Um, a hash table is a collection of items which are stored in such a way as to make it easy to find them later. What you end up doing is taking the value, say for example an ID, and dividing it by a specific number. That then gives you the location where it's going to be stored. Normally what you would do is, let's say for example we have 8 numbers we want to store. Then we want to get a list that's going to be larger than that 8. The ideal situation would be to use a prime number for the size. In our example, we're going to use 11. Okay. So I've got kind of an example here. So let's say we create the list of size 11, 0 through 10 for our indexes. We're going to initialize everything to none. That way we know when we have empty slots on there. Okay. Now, what we're going to start with here, we're going to have 6 numbers, 54, 26, 93, 17, 77, and 31. We want to be able to store these in our list. Now, you have to remember that in order to have a one-to-one correspondence on something, you'd have to be able to have a slot or an opening for each value that's possible, which isn't always feasible. For example, if you were using Social Security numbers, which nobody uses anymore, but let's say that you were, you'd have to have a billion slots, even if you only had 20 people, because you would have to have a slot for each Social Security number. Doing it this way, what we can do is get a value. In this case, we're going to use 11, and divide the number by 11, and then use the remainder for the slot. So example 54 divided by 11 is 44 with a remainder of 10. 77 is 7 with a remainder of 0 down here. So you can see how that works now. So that's how we're going to start off with this. So when we get done putting those in, this is what it looks like. Now, one of the big problems with hashing is that you can have two numbers that hash to the same location. Let's say, for example, on this one here, the next number that we're going to have, let me get down here, is 66. Well, 66 is going to be 6 with the remainder of 0. Okay. 0 is already taken up. So our problem now is, what do we do with our 66? Well, there's two ways to handle it, and I'm going to talk about both of these. I'm pretty sure I think I do, yeah. One way is to just look for the next available slot. So in this case, then the 66 would go into slot 1. So when you go to find 66, you would do the hash on it. Notice that it's already occupied at position 0 and it's not 66. Then you would do a search until you find it. That's where the overload comes, or the overload comes in on here, is that it could take a while to do that. Another solution is that each one of these slots is a list also. So then 77 is already taking up slot 00. So what we would do then is put 66 in slot 01. So then we're doing a different type of search, but it would be a faster search because we know that it has to be in this position 0 here. Okay, so that's what we're going to work with on here. I'm going to pull up an empty Python, and we're going to start creating this program on here. So we're going to create a class called hash table, and our init, we're going to have a size, which we're going to set at 47. We're going to have slots, which is going to be equal to, we're going to set this up, initializing them all to none for our size. And then we're going to have our data is going to be equal to for the same thing, self.size. Okay, so the first method we're going to create is called put. That's the one to actually put it into the value that we have into our hash table. Call it put. We're going to pass in a key and the data. Okay. Hash value is going to be equal to self.hash function, passing in the key and the length of our slots. Okay, so we'll get to the hash function here in a minute. But what this is going to allow us to do is come up with what our hash value is. Okay. So now we want to check to see if our self.slots hash value equals none. That's where we want to put it. Okay, get something off here. Oh, there it is. I got a bracket in there that shouldn't be there. Nope. Okay, that bracket should be there. I need a bracket over here. Close that off. There we go. So if that's equal to none, self.slots hash value is going to be equal to key, and self.data hash value is going to be equal to data. Okay. Else, so now we need to determine what to do here. If self.slots, I have a hard time saying that for some reason, hash value equals our key, then self.data hash value is going to be equal to data. This would mean that we're replacing the data that we had with the new piece of data. Just my bracket there. Else, next slot is going to be equal to self.rehash passing in hash value and the length of self.slots. So what this is going to do then is the rehash will come up with a new location to place our value. Okay. So while self.slots next slot does not equal none, and self.slots, next slot, does not equal key. We're going to print new slot, self.slots. This is just to show us where we're putting it for our own purposes here. And then next slot equals self.rehash next slot length of self.slots. Okay, so once this is done here, we're going to have an if statement right here. Not right there. If self.slots next slot equals key, I'm sorry, equals none, and self.slots next slot equals key, and self.slots, oops, sorry, that'll be data, self.data next slot equals data. Else self.data next slot equals data, and again that's going to be a replace on there. Okay, that's our put. That's getting the value put in there. Next thing you want to do is our hash function. Okay, that's our hash function up here, the call to hash function there. So all we're going to do here is return key mod size. Okay, so that's going to hash our number, get a value for us that matches up in our list so that we can put it in there. Our rehash, passing in old hash and size. This one's going to return old hash +1 mod size. Okay. And the reason that we're doing this is to actually get the next one there. So old hash +1. Remember old hash on our rehash up here. We passed in the next slot. Okay, and then we added 1 to it to go to the next one, and then recalculate that out. The next one we have is our get. So in this one here, we're going to have our start slot. That's going to be equal to self.hash function key, and then length of self.slots. We're going to set data equal to none. Oops. Stop equal to false, and found equal to false. Position going to be equal to start slot. So now, while self.slots position not equal to none, and down the next line here, not found and not stop if self.slots position equals our key, then found equals true. Data equals self.data position, else position equals self.rehash, passing in position and length of self.slots. See a bracket there. Oh, no, those should be parentheses. There we go. Okay, so we're doing all this in order to be able to get the data out of the hash table that we're looking for. And we have to find the location. And if it's not in the position where we first look, not equal to none, okay, then that means we found a location, but we don't know for sure if it's the correct location. Okay, so we have to see if it's equal to the key, and if it's not, if it is, then we said found equal to true. We found the right place and everything. Otherwise, and we said data equal to self.data position, so we're pulling that out, storing it into data. Otherwise, we've got to rehash to the next location. Okay, so once all that's done, and that means that we finally have the data, we're going to return data. Okay, our next one is get item. Okay, this is a helper. That's why the underlines are on there like that, so that you can't call it directly. This is going to return self.get key. And then we have set item, passing in key and data. And this is calls self.put key data. Okay, so that's the whole hash. So now we're going to test it out, see how many errors I have in here. So that's our class. Got everything in there on that. Okay, I'm off from my indentations here. So I'm going to fix all these, because these should not be under the put. They should all be out on their own inside the class here. And I got off on that, and that's something that happens. I'm going to see if this is going to work here. Nope, it didn't. Try one more thing, and if it doesn't work, then I'll do it by hand. Nope, didn't. Okay. That's what I was afraid of. It doesn't work like Word. Almost there. And that one. Okay. So we got all that done. Back up all this stuff here. And we're going to do our main. And what we're going to do is add some items to the hash table and then process these. So we're going to have h is equal to our hash table. And then we're just going to create a bunch of stuff. So we're going to do h54 is going to be equal to cat h26 will be equal to dog h93 will be equal to lion h17 will be equal to tiger h31 is going to be equal to bird h44 would be equal to cow h55 would be equal to pig h20 equal to chicken. And then we're going to do a bunch of print statements here to print out the information. So we're going to do a print after adding 8 items. We're going to print h dot slots. We're going to print hash 20 h20 hash 17 then we're going to do a h20 wrong one, h101 is going to be equal to penguin, and then h20 is going to be equal to duck. So notice we already have a 20 in here, which is chicken, so this one should change that to a duck. Okay. And we're going to print hash 20 oops, misspelled that. Get that fixed. And we're going to print hash 17 oh, I'm in the wrong place here, sorry. You got the 101 okay, so we did this 2017, we changed 101, so these aren't here. I got off the wrong line there, so let's take those out of there. We're going to print change hash 20 from chicken to duck and I'll print hash 20 so we can see that, and then we'll print hash data, and then do a print statement that actually print that h dot data. Okay, so let's run this and see how bad it comes up to be. First error, way up there. That is in my get. This one here is not supposed to be there. It should have been rehash passing in position and the length. See where that one is. Yeah, okay, self. Equal, and that should be none. I got two errors in one place there. So self dot slots net slot equals none. Equal out of that one. Another error. Return key. Someplace in here. I misspelled size. See, this doesn't find it. Okay, we go back over here. So I got, yeah. Okay, so let's go back through and look at size and size. Wait a minute. There it is there. I found it. It's up in here where I say size here is hash function, and this should be size here and not data. Okay. So we got another one. Misspelled self in start slot. Right there. Thanks for being patient with me. I'm finding all my errors in here. If I just redid this video, there we go. Okay, so we added 8 items on here, and you can see them in here. There's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we got all 8 items in there. Hash 20, chicken. Hash 17, tiger. New slot 55. Change hash 20 from chicken to duck. Okay. Hash data. And so now there's the cat, pig, penguin. You can see all these in here. And where is our duck? There's our duck. Okay. So you can see that it does work on there. Now I did a size 47 on this, I believe. 47, which is a prime number. We only have 8 items that we put in here. I could cut this back to 11. Okay. And I think that's the only place I'd have to change that. Well, take that back. Nope, that's right. Okay, so let's go ahead and see what happens if I run this with the 11. Okay, you got a self data next slot right there. Okay, let's try this again. This is why you test stuff out all the time with everything. There we go. So now I did it a little bit different. So the data in here, we got 44, 55, 20, none. Okay, so we did 11. So 54, okay, 44 and 55 would hash to the same locations. Okay, so we look over here at the numbers that we have for these. So 44, 55 would hash to the same locations with that being 11. There may be some other ones that do the same thing. So the 44 goes in, and then the 55 has to go down to the next one. Okay, there's 20, and then here's the other ones here. Okay. Hash 20 is chicken, hash tiger, or hash 17 was tiger. New slot 54, new slot 44, new slot 55, because we tried to do the 17 and it kept moving on there, the one that went in there. Change hash 20 from chicken to duck, and cow, pig, there's our duck right there. See, so it is working, okay? And it works with different ones, but notice though that as we put these in here, we get fewer and fewer nuns in here. And once it gets full, then you can't add any more to it. And when you have a lot of values going in and you don't have very many empty slots, chances are you're going to run into more of what are called the collisions and have to work with those. And then you're doing a lot of searching through it to find the right one. So some things to think about when you're working with hash tables. Okay. Thanks a lot for watching. Bye.